about a broader idea about the climate science, climate change, mitigation, adaptation. That today in this lecture we will learn more about the science part of it and what exactly is the climate science, what is the climate change, what is exactly the global warming, how global warming leads to the climate change, and what are the different components of the earth where we actually see that yes, there is a change in the climate system, there is a change in the specific domains of the earth system. So these are some of the things that we learned today in this class. So this is the content of this lecture, that we will get to know about the drivers of the climate system, energy distribution across the earth, cause of global warming, impact of climate change on land, from drought to floods, oceans from sea level rise to heat waves, from melting of glaciers and ice sheets. Then we will have one more, let's have a young generation's perception of climate change. So I will ask a lot of questions to all of you. What are your perceptions about the climate change? And how are you going to contribute in order to mitigate and adapt for the climate change? Okay, the note, whatever the plots or the figures you will see throughout the presentation, they are not mine. I took it from different sources so that I can make the presentation as interactive as possible. And be ready for the surprise quizzes. Even though I already announced it as a quiz, but still. But the surprise is in the content, in the questions. So that's a surprise. So I request everyone to focus so that you can get 10 out of 10. If you have any question, please let me know. If you do not have a question, then I will ask you the questions. So be prepared both sides. Okay, so let us see where we are in our system. So this is our solar system and this is our Earth. Earth, which is where 8.7 million species live, including the humans. And now we will see what the humans did so far to our climate, to our Earth system. And these are some of the major domains of the Earth system. It starts from the lithosphere, biosphere, there's a hydrosphere, there's a atmosphere, and then there's a geosphere. So atmosphere is basically the thin layer of gases, majorly the nitrogen and the oxygen that constitute around 99% of our atmosphere. There's some other elements, so there's a carbon dioxide and the H2O. So these two are the very less amount in the atmosphere, but that's why the problem starts. So these are the two elements that creates more problem in terms of the global warming. Then we have the hydrosphere, which includes the liquid water only, inland water, water bodies, and groundwater. Majorly the fresh water, including both the salt water. And then we have the cryosphere, is again the subpart of the hydrosphere, which contains the frozen water, which include the glaciers as well as the ice sheets. Then another component is the geosphere or the lithosphere, is both the same as a solid earth, the core, mantle crust, and soil layers. So please note that the soil layer is very important for us. We will talk more about it. Then we have the biosphere, where all the organisms are part of the system. Okay, so let's now try to understand how the climate first. This region is what we call the tropical regions, and there is some other part as well, subtropical region. The other part of our climate system is called the mid-latitude or temperate zone. The other part is the polar zone. And each of these regions have specific characteristics in terms of temperature, in terms of precipitation, in terms of biodiversity. So the temperature, rainfall, humidity, diversity of species, seasonal variations. So you will receive an assignment where you will get a data of temperature and precipitation, and then you have to do certain analysis and then make comments on whether you are whether the characteristics of the temperature are more related to tropical regions or subtropical or temperate regions. You have to basically do that. So you will receive an assignment either tonight or day after tomorrow. Okay, these are some of the characteristics of the basic characteristics of the different climatic zones. Let us say if we see the tropical regions, so tropical region is basically from the equator to the 23.5 north or south. That is this region. So if you look at the sun part, basically the sun part represents the angle at which the sun rays hit the earth. So over the equator you will see that it's only majorly the 90 degree, and over the year it changes to 43 degrees. It will never go beyond 43 degrees. Let us say this is the earth, the sun is here, it strikes the earth at a 90 angle. It can go to the 43 degrees, but it will never go beyond that. And the average temperature of the tropics is greater than 20 to 30 degrees Celsius. This is an average temperature, but if you can see the Tmax and Tmin, the Tmax is around 40 degrees Celsius. But if you see the news reports so far from last couple of weeks, you will see that this region is in the tropical region. The temperature was more than 40 degrees. It was around 41 degrees. Similarly, the Tmin is 0 degrees. So it never goes beyond 0 degree. As a result, you will never see a snowfall in tropical regions. If you see the precipitation, the high amount of precipitation of the tropical regions is around 1800 to 2500 mm. And the climate is humid and warm. Similarly, if you see go beyond the tropics, you see the subtropical regions. These are the characterization of it. No doubt in the subtropical region the temperature is comparatively higher as compared to the tropics. And when you go to the temperate region, again the temperature is, the fluctuation of the temperature over the time, the Tmin goes to minus 40, the Tmax goes to 40 degrees. Okay, so now the major thing is that over the tropics we don't see any kind of seasonality. We don't have the winter and the summer over the tropical regions. The temperature is more or less moderate over the tropical regions. But if you go to the subtropical regions, and the tropic temperate regions are mid-latitude, you will see there is a seasonal variation, right? We have the winter, then spring, then summer, and then autumn season, and then back to the winter season. But you will not see these kind of seasons over the tropical regions. Okay, so then the question is, what is the cause of seasonality? How come we are getting the summer and the winter? What's the major reason of summer and the winter? Any thoughts? Yeah.
Tilt of the earth relative to the sun.
Is it the elliptical orbit of the earth or the tilt of the earth? Right? Any other thoughts? Is it that the elliptical orbit, we know that the earth doesn't revolve in a circular form, it's an elliptical shape, right? Or is it that the tilt of the 23.5 degree tilt of the earth? What is that? That causes the seasonality of winter and summer, yes?
Is it both?
Both? Yeah. Okay. It's actually the tilt of the earth that creates the winter and the summer season. If you see here the March 21st, even though the northern hemisphere is close to the sun, but still we see the temperature is not that high. But when it reaches to around June, mid-June, that's when the northern hemisphere receives a lot of heat or the temperature, solar radiation. And then it shifts towards the September, and then autumn still starts going, and then the winter. And in the winter of the northern hemisphere is basically the summer of the southern hemisphere. So here you can see the northern hemisphere is facing the sun, and here you can see that the southern hemisphere is facing the sun. Rest side we will go into alternative, summer and winter. You can get more information here. This is the summer of the of the northern hemisphere, and this is the summer of the southern hemisphere. The elliptic arc has nothing to do with the seasonality. Even though we are close here, but we are not receiving that much of solar radiation. Now this is very important. How much solar radiation we are receiving, how much the Earth is receiving the solar radiation, that's very important. One is that the intensity, and the second is the duration of the solar radiation. Are we receiving the solar radiation just for the 10 hours, or are we receiving the solar radiation for 25 or 15 hours or 12 hours or just 6 hours? If you receive the solar radiation just for 6 hours compared to the one that receives for the 12 hours, you will see that the temperature difference will be comparatively higher. Okay, so this is what I was talking about, that over the tropical region, the sun hits the Earth directly at an angle of 90 degrees. As a result, if you see here, the area it covers is comparatively less compared to when it goes to the higher latitudes. See the area it covers. That's one reason, that as we go higher to the latitude, the temperature decreases. This is one of the major reasons. But there are other solar reasons. This is just a solar footprint, where the area that it covers. The second thing is the atmospheric absorption. We have less atmospheric absorption here compared to the higher latitudes. And then we have the albedo effect. You know what is albedo effect? The reflection of the sunlight. Please note that this is a reflection of the incoming sunlight from the atmosphere, and the albedo is a reflection from the surface of the Earth. We know that the sun is, the ice as well as the snow, it has a high albedo effect. It reflects a lot of energy back without absorbing it. But the oceans, where they absorb a lot of energy and emit less back to the space. Because of all these reasons, we see that the tropical region receives a lot of heat compared to the polar regions. See here, we are gaining the heat here over this location, and we are losing the heat over the polar regions. So now, this is because we are getting a lot of the reflection from the ice as well as the snow. When the sun rays hit the ice, it gets reflected back without absorbing it. And that's why we are losing a lot of heat here. But we are getting a lot of heat here because majorly this part is covered by the oceans. And as well we are getting a lot of heat here. Now that's where now the problem starts. Is that we need to dissipate this energy from the tropical regions toward the poles. That's the only way we can maintain an equilibrium of the Earth system. So what are the ways by which we can actually dissipate the energy from the tropical regions toward the poles, so that we can maintain a specific temperature over the Earth? So before we go there, what are your thoughts about if there is a global warming? How this curve will change over the time? Any thoughts?
Would it just get like sharper like the equatorial regions? Like all regions would increase.
Are you saying that this will go this way?
Yeah. Like the equatorial, everything increases, but the equatorial regions just increase at a faster rate.
At a faster rate? Okay. Anything else? Yes, random guess. Okay. Just remind me of this slide. We will come back again and we will understand the global warming. Then I will come back again, and then you might be in a better position to answer this question. Okay. Polar region is always considered colder than the equatorial zone, but temperature difference remains the same. Even though we are receiving a lot of solar radiation over the tropical regions, or at the equator compared to at the poles, but the temperature difference has not been changing much over the time. over the years. Why is it that? Because there is a dissipation of energy through the circulation of oceans as well as the atmosphere. So atmosphere as well as the oceans helps us to dissipate that energy from the equator toward the poles. And this is how the atmosphere helps us to dissipate the energy from the tropical regions from here towards the polar regions, towards this side. And then we have these ocean currents, surface ocean currents, with these red. So these are the ones that carry the warm water toward the poles. And then we have these blue lines that actually bring the cold water from the poles toward the equator. And this is how, these are three major mechanisms. No, there's another one. One is called the deep, this is surface currents, and then this is called the deep ocean circulation. And this deep ocean circulation also helps us to take the warm water away from the equator and bring the cold water close to the equator in order to maintain the temperature of the earth. Now let us see in more detail of these three circulation patterns. I am trying to emphasize you about these things because that's why this is a core of to understand the climate science and the global warming. These three regions. I might ask you the question is about what are your thoughts about how these things will change when there is a global warming, when the temperature of the system increases. How is this circulation going to change? How is this circulation going to change? How is this circulation pattern going to change with the global warming? So how many of you know these things? Okay, let me ask you the question. Let's say this is a warm air parcel and this is a dry air parcel. In a warm air parcel there is a lot of water, but in the dry air parcel there is less water. Which one will rise and which one will go down and sink? Yes. Warm air rises, but it has a lot of water inside it, right? Let us say I have a cup full of air and full of water, half of the water, right? Which one will be heavier? Water. So that implies we are saying that the warm air parcel will sink down because it has more water. Compared to this one, it doesn't have more water. Are you able to follow me what I asked? Which one is denser? This has a more density or this has a more density? Warm air parcel has a more density. But if it has a more density, then it will sink down, right?
Yeah.
Then you are changing the concept of evaporation. So the answer is in high school chemistry. We have the nitrogen, we have oxygen, we have H2O, water. If we know the molecular weight of the nitrogen, water, and oxygen, right? The nitrogen has 28. The oxygen, H2O has just 18, 16 plus 2, 18. And oxygen has a 32. So the more you put the water inside the parcel, it will remove the nitrogen and the oxygen. The more it will make it less dense. That's why the warm air parcel is less dense compared to the dry air parcel. Okay, so this is just a pictorial representation of how the warm air parcel goes up and then the cold air sinks down. And this is exactly what we see in the atmosphere. But over the tropical regions, because we have a high temperature, the high temperature actually leads to the density of the air parcel goes down. When the density of the air parcel goes down, it starts rising up. And the warm air parcel or the equatorial region has a lot of water content inside this. So when it goes up, so here at this location it starts condensation. The condensation process starts. So as a result, you will see a lot of rainfall over the equatorial region. and it will be always cloudy. You will never see a clear sky over the tropical regions. If you will see the clear sky, we have 1 month here, please let me know. But you will see very good sky in USA. There's a reason for that. And this is the major reason. We will never see a clear sky over this region. It's always cloudy. Because there's a lot of evaporation that goes here. Why? Because of solar radiation will increase the temperature increases the evaporation. And that's how it cools down the surface. Evaporation brings the cooling, right? When, okay, this is, so when the air parcel goes up, we will see a lot of rainfall here because of the condensation, because the temperature goes down at this height. Then the air parcel starts moving towards these directions. From high pressure, here is the high pressure to the low pressure. And then it sinks down here. So as it reaches the upper latitudes, towards the poles, then it starts getting cold. When it starts getting cold, it starts sinking down. And that is exactly what we are seeing here. This is called the ideal global circulation patterns. It has a very good relevance with the exact form of our landform. See here, this is the tropical region. This is the equator. While there's a lot of evaporation goes, as the evaporation goes, we will see a lot of clouds over this region and a lot of rainfall over this region. Then, once it starts rising up, then it starts moving towards the poles. At a specific location, because the temperature changes, it starts gaining the density. When the air parcel starts gaining the density, it starts hitting back to the earth. And that's the reason here you will see the low pressure system, where the pressure is low, and in this region you will see a high pressure system. Now it has a relevance whether it's a low pressure or the high pressure. Do you know that this region is where majority of the deserts are? The Sahara deserts? They're at this location only. And you will see a very good clear sky over this region. And this cell is what we call the Hadley cell. The function of these cells is the same. And this is called as the polar cell, and this is called the feral cell. This is the way the temperature of the earth, the heat at the equator dissipates toward the poles. Then once it starts coming down, the air starts coming down, it strikes the surface of the earth. When it starts moving, some starts moving toward the equator because the equator is the low pressure zone, right? And similarly, some starts moving toward these directions. So air always moves from high pressure to low pressure. Movement of air from high pressure to low pressure is what we call the wind. And these are what we call as the wind. So this is called this is a subtropical high, this region. And over the subtropical high, you will see the dry weather conditions and clear sky. This is the location where you will see the stars more. If you wonder. But this is the location where you will never see this clear sky. When there is no clear sky, there is no stars. You will not see the stars. Then we have the trade winds. Trade winds are basically the air that flows back towards the earth. Once it strikes the earth, it starts moving towards the low pressure zones. And these winds are called the trade winds. Northeast trade winds because of the direction. You know why they are curved? Why these winds are curved? It's because of the Coriolis force, right? Okay. So these are the different types of westerly winds. So here are the westerly winds, these are called the prevailing winds, and these are called the polar easterlies. And the direction changes here in this way. See, this direction and this direction. It's very confusing. If you go into the mechanics of it, it's very confusing. But the point is that these trade winds have a very specific relevance in the climate system. How many of you are aware of monsoon system? Monsoons? Indian monsoon, Southeast Asia monsoon, USA, we also have a monsoon there, right? So these winds are responsible for those things. They bring a lot of warm water from the oceans toward the land masses. We have a very specific relevance there. But let's not go there. The major thing is that here, these are called the surface currents. Have you ever heard about this Gulf Stream? Warm current? And you might also heard about this California current? This is a cold current and this is a warm current. How many of you know that this is a region where we see a lot of cyclones? It is because of the warm water that flows over this region. So basically, the warm currents basically take the water, the warm water from the equator toward the poles, and these cold currents basically bring the cold water from poles toward the equator. And that's how they dissipate the energy, the extra energy that we were receiving at the equator, and the energy deficit at the poles. And these are driven by the winds. And these are the winds that are responsible for them. Then we have another thing that's called the deep ocean circulation, deep currents. And these are driven by salinity and the temperature. And that's called the thermohaline circulation. Okay, just a question. Let us say the saline water and the fresh water, which has more density? Fresh water has a more density or the saline water has a more density? Any thoughts? Let us say if I give fresh water and saline water, oceanic water, which will have the more density?
Salt water heavier?
Salt water heavier, right? Okay. So now we have the salt water and the fresh water. If I mix the two together, let us say there is some separation layer between the two. Then the salt water will go down, the fresh water will be at the top, right? Perfect. So that's the one major reason of these deep ocean circulations. This, the salinity. And the warm, cold water is more dense or the warm water is more dense? Which one? Which one is more dense? Yes? Cold water is more dense, right? Compared to the warm water. Please keep this in mind. Warm water is less dense, it expands. Cold water is more dense, it shrinks. It takes less volume. Because this will come again when we learn about the climate change or the sea level rise. Okay, so this region, this Gulf Stream basically brings the hot, warm water, which is more saline water, from the equator of the Atlantic Ocean towards the North Atlantic Ocean. As it reaches towards this region, it doesn't lose much of the salinity. As a result, it brings more dense water towards this location. Since it mixed there with the more cold water, that's the only reason that here we will see the water sinks down. So this is the location where it sinks down. It's because of the salinity and the temperature. But when it sinks down, then it starts flowing around these regions. And then this is why this cold water rises up. Either here or here, Madagascar region, or here, or this region. Now this has a very specific economical benefits where it rises. The fisheries industry, so you will see lot changing. So now the second part is that still this was when we don't have any issue with the greenhouse gas emissions. Now when the greenhouse gas emissions comes into picture, then the problems start. Now we will learn about the greenhouse gases are good or bad. What are your thoughts about it? Are greenhouse gases good or bad? Any answer? Yeah.
I mean, they're not all bad because without greenhouse gases, our atmosphere like things would respond to it. Like if we didn't have no layer and stuff like that, so just come on, like the instant or in a good way, we would be in a nice situation.
What are your thoughts?
I was going to say similar things. We need them to maintain like a habitable temperature, but to the extent we have them now, that's bad.
Okay. Any other thoughts from this side?
I mean, with greenhouse gas emissions, the warmer temperatures mean that the ocean has a less capacity to absorb CO2. So,
Ocean has less capacity to absorb carbon
so
dioxide.
like it's just a negative feedback loop of less natural buffering.
Or greenhouse gases, good or bad? Bad.
Yeah.
Any other thoughts from this side, back side? Yeah. Right?
Good in moderation,
Good in moderation. And bad?
bad in excess.
Bad in excess. This side, what are your thoughts about it? Good or bad? Or both? So there's a phrase, excess of everything is bad. Just like that. So let us see the Earth without atmosphere. If we do not have the atmosphere, the temperature of the Earth would have been minus 18 degrees Celsius. If we bring the atmosphere, the temperature of the Earth is 15 degrees Celsius. And that is habitable for all of us. A lot of living creatures, including the humans. It's when we have the atmosphere. What is that something in the atmosphere that rises the temperature from this to this? Greenhouse gases. Okay. So let us first see what is the structure of our atmosphere before we go into more details of the composition of the atmosphere. So this is the vertical structure of our atmosphere. We have a troposphere, 10 to 12 kilometers of height. Then we have the stratosphere, then we have other major layers, but that are not much relevant to the climate sciences. Most of the climate scientists work only in this region, troposphere. All the weather activities, whether it's a rainfall, temperature, heat waves, anything that goes, cyclones that goes in this region, for this region. So, one thing is that this is the structure of our atmosphere, and this is the ozone layer. This is ozone layer is basically the top of the stratosphere. And we know what is the function of our ozone layer, right? So, but this is the temperature. This is how the temperature varies as we go higher, higher, and higher. So, I will ask you the question that why is it increasing the back again? Technically, the more you come close to the sun, the temperature should be more, right? But what is happening here? The more I get close to the sun, the temperature should increase. But is this wrong? The temperature curve? As I'm getting close to the sun, the temperature reduces. Then it increases. that. It makes sense because we're getting close to the sun, right? But it doesn't make sense here. There's some other reason for that. Please note that in the troposphere, it is basically when the sun is strike the earth, the warming starts from the surface of the earth towards the height. So it starts warming from here as you go up. And there is a specific reason for this. I will not tell you the reason. If you are more curious about it, you can do a Google search and find the reason. And there is one more hidden question in this plot. When the climate change deniers say that, oh, there is no climate changes, or the climate change is very natural, it's not because of the anthropogenic climate changes, it's natural, or it is because of the solar radiations. If it would have been because of the solar radiations, we would have some changes here also. But we are not seeing any kind of changes over this region. We are seeing majority of the change only in this region. That gives one more argument that it is driven by human anthropogenic climate changes. If it's a natural climate change driven by solar radiations, then there will be changes also in this one. If we are not seeing changes here, we are seeing only changes here in this one. Okay, and the composition of the atmosphere is this. Especially this composition is valid only to this region, troposphere. As I said, for the climatologists or those are the meteorologists, this is a region of interest for them. And this is the composition of our atmosphere, the lower part of our atmosphere. There is the nitrogen, there is the oxygen, and these two constitute around 99%. Then we have the argon here, 0.9%, and some trace other elements, including the carbon dioxide and some other elements. Now, how many of you know about this concept, black body concept? Okay. Any else? In winter, we try to accommodate more people in a room so that the room gets warm. But in summer, we prefer not to do that. Why is that? Let's say we don't have an AC, we don't have anything. In winter, we will prefer more people inside the classroom. But in summer, we will prefer less people inside the classroom. Why is it that? Because every element in the universe, if the temperature is above the absolute zero, when I say the absolute zero, it implies 0 Kelvin. If any of the element has a temperature greater than absolute zero, it starts emitting radiations. When I say the radiation is basically the heat. So that's why in winter we prefer to have more people in the classroom so that we will feel warm. The entire classroom will be warm. But in the summer, we prefer the other way. So as a result, if let us say the room temperature is right now, let's say 23 degrees Celsius, then my body will also start emitting the radiations. If you reduce it to absolute zero, then nobody will emit anything, radiations. And that's what we call the black body concept. That every element in this universe, when the temperature is above the absolute zero, when I say the absolute zero is 0 Kelvin, then the element starts emitting radiations. And that's what is exactly. We know that the sun is the hottest, right? It starts emitting radiations, the earth receives the radiations, and the earth becomes warm, then earth starts emitting radiations. So the sun, because it is, the more the element is hotter, the more it starts emitting radiation, more intense radiation starts. Let us say if this element has a temperature of 10 degrees Celsius and this has a 30 degrees Celsius, this will emit more radiations as compared to this one. When I say more radiations, I mean the intensity of the radiation will be high. More energy compared to this one. So more energy, basically, if we know about the waves and oscillations, more energy means high frequency, short wave radiation. So the wavelength is smaller. And low radiation or the less intense radiation means that the long wave radiations, right? If the signal is intense, then we'll have the short radiations. If the signal is slow, then we'll say these kind of, it's called the long wave radiation, short wave radiations. The sun emits the long wave radiations majorly. UV rays, then it comes to the visible range. There are very short wave radiations. While the Earth emits the long wave radiations, infrared radiations and other radiations. So this is the concept of this Earth energy budget. We are receiving from the sun 340 watts per meter square. Out of that, there is a total reflected from the atmosphere only, it's 53. Then there is an absorption by the atmosphere by 73 units out of that. And the Earth is only absorbing 214 watts per meter square. This much of energy. And because it starts warming up, the Earth starts emitting back the radiations now. Here the problem starts. We have these greenhouse gases. And these greenhouse gases basically absorb these long wave radiations. Once they absorb these long wave radiations, then they start emitting it back. So some of these greenhouse gases emitting towards the outer sphere and some starts emitting towards the Earth. And if we have this greenhouse gas in a large quantity, then they will start absorbing the long wave radiation emitted by the Earth. But technically, the process should be this way. Whatever we are receiving it, and let's throw it back to the space. That's how we can maintain the equilibrium. But when I am receiving a lot of energy, I am not able to emit it back to the outer sphere, because there is some hindrance from the greenhouse gases. Now, if we had a greenhouse gas in the appropriate manner, in the appropriate quantity, then the temperature of the Earth will be stable. But if the greenhouse gases increases in volume, let us say in portion in the atmosphere, then they start radiating back towards the Earth. So this is basically the same example by showing the clouds. Clouds also have its own role. So this is when the clouds are there, and then the reflectance of the incoming radiation is more compared to when we have a clear sky. So if you can relate it a bit here, that's why the tropical regions have a moderate temperature. Because there are always the clouds, and whenever the incoming radiation will go back. A lot of reflectance. But note at the same time, at the tropical regions, we have a lot of oceans. There's a lot of absorption goes there as well. Yes?
I have one question or a few questions just for the class of you. Go back to that earlier thing that you talked about atmosphere. I don't have to answer all of them right now, but when you came on a flight, let's say from when you went from Boston to Dubai or Boston to Japan, by the time the flight reached, the steady level, what was the value in the troposphere, stratosphere, upper atmosphere? What was the
And why there was no turbulence?
Notice that information was flashed somewhere. What was the temperature? I guess if you will, think about that. And so there is this, change of temperature in the atmosphere. If you remember what the temperature was when they're coming down. We have seen it, there is some evidence of that. There's the thing that happens with stratosphere. You may want to see how that relates with one other important human caused change in the atmosphere, which is in terms of the ozone layer, ozone hole kind of. And the third thing is when global warming happens, as it has been happening, what happens to this temperature profile in the atmosphere and what happens to the temperature profile? Cooling, warming, what happens? Those are the three things. But anyway, there are some hand raisers.
Yes.
I'm not sure about all the questions, but I think they're about like 38,000 or 40,000 feet. Like, I would remember for the negative 60 feet there. I'm not sure about Celsius.
So that's why you are here.
Yeah.
And that's why there are more turbulence also. Because this is very steady in terms of the motion of the air. Once you start going down, there is a turbulence. The turbulence starts. Okay. We were there. What was it?
Tropical ocean.
Okay, I was here. So what I'm saying is that whenever we have the clouds, then we have more reflectors from the atmosphere. And now in the next class with Professor Ravit, you will understand why these clouds create a lot of problems. Whenever we try to understand the climate change through our system models. Whenever we start modeling the Earth system, this creates a problem. We will learn more about during the modeling class with Professor Ravit. Okay. So now we're going to define these greenhouse gases. Gases in the atmosphere that traps heat. They pass the shortwave radiation from the sun. They don't have any problem. Whenever there is a shortwave radiation from the sun, they allow it easily. But whenever the Earth starts emitting the radiations, they come to block it. So there is a one pass. They pass the shortwave radiation, but they absorb the long-wave radiation from Earth. And that's why the problem starts. And then so they start, radiating it back toward the Earth, toward other greenhouse gases, and to outer spaces. So these are some of the major greenhouse gases: methane, nitrous oxide, carbon dioxide, ozone, chlorofluorocarbons, carbon monoxide, and sulfur dioxide. These are some of the major greenhouse gases in our atmosphere. Some are in major portion, some are in less portion, some are more potential toward the global warming, some are less potential toward the global warming. But these are and this is exactly what they create. Increasing greenhouse gases is like adding more blankets. So this is exactly what they are doing. Okay, here's the carbon dioxide. It's a naturally occurring molecule in the atmosphere. And the source of these is the burning of fossil fuels like coal and oil, most important contributor towards human caused global warming. Then you have the methane. Methane again, it's a natural. It comes from the wetlands. You know what's wetlands? Wetlands? Can you tell?
It's like, what is it?
The wetlands.
What about?
What are those?
They're like swamps, like,
Yes.
it's like areas of land where there's a lot of water on the ground.
So then growing rice, those who are a fan of rice, the methane comes from there as well. I am the one. The rising cattle, the beef eaters, then using natural gas and mining coals. So these are some of the sources of the methane. This is the second most important contributor of human-caused global warming, or the greenhouse gases. The first one is the carbon dioxide, and second is the methane. And please note the chemical composition of these: CH4, CO2. We will not go into the chemistry of it. What exactly is the chemical bonds that actually trap that energy? How it is allowing the short wave radiation but absorbing the long wave radiation. We will not go there. If you are interested, I can point out to specific readings. If you are interested, the chemical nature of these things. Then we have the nitrous oxide. Again, this is a natural part of the nitrogen cycle. Bacteria and from the oceans, the source of this nitrous oxide. But the nitrous oxide we are emitting into the atmosphere coming from the factories, power plants, fertilizers, damages the protective ozone layer and is a powerful greenhouse gas. When I say the powerful greenhouse gas, we will discuss what does that mean, powerful greenhouse gas. Then we have chlorofluorocarbons. Now these are the major emissions that create the ozone problem, ozone depletion. It's not a naturally occurring. We have created these chemicals. That's why it's written here. You thoroughly should not have created them here. So then we have the water vapors. Water vapors also act as greenhouse gases. They also absorb solar long wave radiation. So when there is an evaporation, lot of water vapors go into the atmosphere, as well as they start trapping the heat. So that's the reason we would say that there is a humid somewhere, humidity. That humidity comes from this water vapor. And then we have the ozone. Well, ozone is good for us because it protects us from the ultraviolet radiation, but if it is in the lower atmosphere, then it creates a problem. It's a greenhouse gas there. So I was telling you that what's the global warming potential of greenhouse gases? Let us say if there is a carbon dioxide. Let us say 1 kg of carbon dioxide. For example, 1 kg of carbon dioxide we have, and it increases the temperature by 1 degree. If we have a 1 kg of methane, it's equivalent to 28 degrees Celsius increase in temperature. If we have these hydrofluorocarbons, it has 164 times. Nitrous oxide, very powerful, 273. 1 kg, for example, 1 unit of nitrous oxide will raise the temperature, has the potential of global warming by 273 units. So these are very powerful as compared to the carbon dioxide. But the problem with these is that they stay in the atmosphere hundreds of thousands of years. The carbon dioxide molecule in the atmosphere. If you emit the carbon dioxide molecule, it will not go down. It will stay in the atmosphere for hundreds and to thousands of years. But with the methane, it stays for just 30 to 40 years. Similarly, the nitrous oxide, it stays in the atmosphere for 100 to 120 years. And this is the contribution of these three major gases. Carbon dioxide is around 70%, then methane around 20%, and then nitrous oxide around 78%. This is the contribution of different greenhouse gases out of 100. We can see here the carbon dioxide. That's why most of the narrative goes on the carbon dioxide, how we can reduce the carbon dioxide. If we can at least manage to reduce it by half of it, then we can solve a problem. And the problem with them is this one. They stay in the atmosphere for hundreds and thousands of years. That's one more major problem with this. Then this is the question for everyone. Rank the following countries based on the emission. Which country emits more? You have to rank it. Please go ahead. I will point out space. Let me, Parker, what are your thoughts now?
Are we ranking them per capita or just?
Let us say per capita or total. It's a country wise or just cumulative.
China, then India, then US.
So you are keeping both the Indonesia and the Thailand at the end, right? Okay. Okay, this side. Meher. Where else?
Ever or like
Sorry?
eating
Total. Let us say the current. Yes.
I don't know. US and
Indonesia and Thailand. And let us say now I will change the question. What about the per capita? 7.
per capita,
Yes.
US,
Okay. First. US, India, China. We are saying US, India, China, then
Thailand and Indonesia.
Thailand and Indonesia, right? How many of you agree with her? Yeah. Do you agree with this ranking? US, India, China, Thailand, Indonesia.
I think US, Indonesia, India.
US, Indonesia, US, Indonesia, China, right?
No, US, Indonesia,
India, China, and Thailand. Per capita, right? Okay. So we will visit to this website and we will actually understand which country emits how much of carbon dioxide. Before we go there, this is the greenhouse gas emission cumulative. It's in before the industrialization starts, 1850 around. So you can see the US is around here, 1 billion ton to 3 billion tons. And these European countries, China, India, they were emitting very much. Now look at the 2022. See why the US is, why the China is, India, and these countries as well. Look at the change in this country from here to here. So this is a total cumulative. Take the United States, China, they are around 10 billion tons. This is world total carbon emission. Let us start it from here, the 1850. The world was 2.22 billion tons. USA was first, then China, then India, then Indonesia, then Thailand. And what has changed over time? The world 53 billion tons. Look at the change from 2 billion tons to 53 billion tons of carbon dioxide into the atmosphere. Similarly, China. China was 448 million, now it is 13 billion tons. Similarly, the United States is 6 billion tons. India, 4 billion tons. Then we have Indonesia. Look at the Indonesia and India. Even though India is a big country, it's emitting 4 billion tons. And India is a small country and it is only 2 point, it's only half of it. We will see in Indonesia what has been done. What will be in Indonesia? What is the reason of emitting that much of carbon dioxide? Similarly, Thailand is emitting less also. But this is the total cumulative. When we go into the per capita, you can see here now, US, Australia, this, Mongolia, and here we are. Per capita, 20 tons of, around 10 to 20 tons of by this country, USA. But Canada emits more per capita. It's It's above 20 tons. Similarly, if you see the Australia is above 20 tons per capita per year. And here we are. This is the USA. Per capita per year to 17.7 ton per capita per year. So we can see the improvement there in terms of reducing the carbon emission, but it is beyond all other countries. And this kind of graph, now let us look into the China. Here we have China is 1.4 ton and it has reached to 9.8 ton. There is significant 2 to 3 folds increase in the carbon emission. Now look at the India there. It's 1.4 ton. It has reached to 2.9. It's around the double. But look at Thailand and Indonesia. Here's Indonesia. How much it was? 5.1 ton and this is 7.1. So Indonesia per capita, they are emitting more carbon dioxide per year as compared to the Indian population. Yes?
What happened around like 2000? What is that massive spike?
So this year,
Yeah.
I have no idea.
But it's so dramatic.
Well then why don't you take your assignment? Either that there was a change in the policy or either that there was a change in the climate system, but I will not ask you this question in the assignment. What exactly happened in Indonesia at that time? Because I don't know the answer.
Even as an answer, she'll explain eventually.
So the moral, the conclusion from this plot is basically that both Thailand and Indonesia are emitting more carbon into the atmosphere compared to the India. In news, in different social media, you will see that China, India, they are emitting more. But if you look at the per capita, the USA is beyond all other countries. And this kind of loss has very strong correlation with the GDP of the country. The more you are emitting the carbon dioxide into the atmosphere, the more good you have the GDP. The more the environmental impact. So it doesn't come like that, okay, I'm emitting less and I will have a high GDP. So there is a trade-off between the degradation of the environment and the GDP growth index. Yes?
Why is Mongolia so high on emissions per capita?
Yes, that was my question also. Even if you look at the methane emission, they are emitting more methane compared to all other countries. I will go into this website now. Yes. So I will share this link with all of you. If you go down, you will see the world here. So I can here just go to the countries. I can India, USA, Indonesia, China, you can see the carbon emissions. Now I showed you already those things. These things I already showed you. I want to show you the methane emission from different countries. Look at the methane, how it has changed over time. This is a cumulative. This is how it's changing. Now let us look at the per capita. See here, let us start from here. That's a per capita. So now look at this country. 9.7 ton. USA just 2 ton. Uzbekistan. So there are some other good plots in this website. Per capita nitrous oxide. Again, these Mongolians are emitting more. Okay, coming back to the what has happened here? So you will receive an assignment based on these things. And Diane will talk more about this carbon emission, if we reduce the carbon emission, if we do this policy, if we do that policy, how the carbon emission will look like in the future. Okay, so now we observe that okay, there is an increase in the carbon emission, there is an increase in the greenhouse gas in the atmosphere. But is there a relation between the carbon and greenhouse gas emission and the temperature? And that's what we are observing here. Look at the time scale here. 400,000 years ago. This is a present time scale. We see that whenever there is an increase in the carbon dioxide, greenhouse gases, it follows the temperature follows the same path. Right? In previous carbon levels are higher. So what is all the fuss about now? In the past also, we can see here the temperature. We can see here the carbon dioxide was higher in the past, and the temperature as well. So what's the big deal? Any comments on that? In the past, we observe high carbon emission and high temperature. So what's the big deal now? Why we are investing so much in the climate science? Yes.
Well, it looks like the peaks in temperature were short-lived, whereas now it seems to be at a high level.
Okay. Any other thought? What's the big deal now? Yes. So what if tomorrow it will go down? What if tomorrow it will go down? So we have seen here that when it goes up, then it comes down. So naturally.
I think it's just like increased so much.
The rate, right?
Yeah.
The rate of increase. And one more factor is that it's more relevant to us now because over this scale the humans are not present. So it doesn't matter that time. Now it matters a lot. And if you look at the rate at which it is increasing, the rate is one that we care about it. And the second thing that's more important is now we are living in this world. Initially we were not in this world. We are two major things. The rate at which it is increasing, it is much faster than what we observed in the past paleoclimate. Studying the Earth, past of the Earth is called paleoclimatology. So first the rate at which the temperature is increasing with respect to the carbon dioxide or with respect to the greenhouse gases, the rate is much higher as compared to the previous thousands of years or so. And the second thing is that the humans were not present previously because it's affecting us. We will see now how it is affecting us. So look at the recent rate, the global temperature, how it is increasing, and how there is a strong correlation with the carbon dioxide as well. The carbon dioxide is increasing, global temperature is increasing. Then these things will help you in basically the war games. I put it deliberately here. You can see the contribution of different fossil fuels for the increase in the temperature, 1.61 degrees Celsius increase in temperature compared to the industrial era when the industrialization was started in 1800. 1850s around. That's when the people started emitting more carbon dioxide into the atmosphere. Like if we take that as a baseline, the temperature has increased by 1.61 degree, and different greenhouse gases have a different contribution to it globally. But the more interesting is here, if you look at the United States, the majority of the increase in the temperature comes from the fossil fuels, and industries. But if you look at Indonesia and Thailand, the majority comes from the land use, land change, rather than the factories and other fossil fuels. So there's a change, the kind of agriculture and the land use. Two different, is a contrast, right? From here to here. So it is not that the Indonesia has a lot of factories and all those things, or the industry. It's because we are changing the pattern of agriculture as a land use. That's the major reason. Why are we? Okay. Now, concluding this, all these greenhouse gas emissions is that we are receiving more solar radiation, but the Earth is emitting less solar radiation. That's the problem. That we are receiving more energy, but we are emitting less energy back to the atmosphere. And the extra amount of energy or the heat we are receiving, 93% are going to the oceans, and 3.5% going into the land, and only the atmosphere holds on 0.7% of the heat. The 93% of the total heat, the extra heat we are receiving because of the global warming, goes into the oceans, and only the 0.7% goes into the atmosphere. We are saying the surface temperature increase. It is only because of 0.7%. We are not taking care of this part. The 93% goes into the oceans. So then if we have this extra amount of energy that goes into the different domains of the Earth system, whether in the ocean, in the glaciers, or in the land, then we will have different impacts. That's why now the climate change starts. That we have increased the temperature of the system that will lead to the melting of glaciers. When the glaciers will melt, it will increase the sea level rise. When the sea level will rise, it will lead to the flooding conditions. The other side of the coin is that because of the climate change increase in the temperature, the soil moisture content inside the soil reduces over the time. And we don't receive a rainfall for a longer time, end up having the drought. And the temperature is higher, we end up having the heat waves, drought. Then when the soil moisture content is not that much, the temperature is high, it is an ideal scenario for the forest fire. And all of these things leads to the biodiversity loss and the water scarcity. When these two combine, they lead to the human displacement along with these two. When we have a human displacement, that creates a problem. Human displacement within the country, and some people go outside the country as well. And then the developing nations bring the policies that we cannot take the refugees. And who will take those refugees? If you have emitted so much of carbon dioxide into the atmosphere, you are responsible for the carbon dioxide or the greenhouse gas emissions. Then now you are denying that we will not take the refugees. For those who are working on the international affairs, they can think about it more. Who will take responsibility of climate refugees? Climate refugees are basically the people who are getting displaced because of these events. If somebody is studying the international affairs, this can be one of the topics. Then the water scarcity. Everyone has a right to have a drinking water. But we are facing that problem as well. Who is taking that responsibility? Who will take that responsibility? Okay, now let us let us try to understand the climate change on different domains of the Earth system. We have 40 minutes. What about the quiz, Professor? You were supposed to submit a quiz, right?
Yeah. Now is a good time?
Yeah, I mean, I can take the rest part of it.
I think many of them have submitted the quiz, and it was optional, it was not mandatory. All of them submitted it, okay. This doesn't count towards your grade, we can just, the first one or two or three, you will have, they will be dinner or something. I haven't looked at all your responses yet, I'll do that, but the first, I saw that some of you were absolutely right. The first one is Svalbard, which is the northernmost part of Norway, or northernmost part of the planet Earth, which is continuously inhabited. Some of you said I could find that through reverse image search, whatever. Whatever you did is fine. I did not impose any constraints. So whatever you did is fine, but as long as you have the answer. Do you have access to your Google Scholar, or you just on your computer? Not Scholar, sorry, any browser or your computer.
Yes.
You can type Svalbard, Svalbard.
SVAL.
And there you go. That's the place. It's many months is night, and of course some months it's day. It's very cold, and that picture is from glacial cave, which by the way changes every time, and it is there's some ice there which is fairly recent, and some ice there which is thousands of years old. The other video, so anybody who just show up hands, anybody who put up this cruise, Svalbard, Norway, in your response? Just show up hands, because I think some of you did say that. The other one is Maldives. This is the coral reefs near the Maldives. If you just please search Maldives coral reefs. So one is right at the northernmost continuously inhabited part of this planet. The other is, the equator. All the beautiful coral reefs. The climate impacts, coral reefs are getting bleached because of climate, and I think Danish did talk about that, or we talk about that just a little bit. And climate change is what we call a polar phenomena, in the sense that there is polar amplification. A lot of the warming that's happening, much more warming is happening in the polar regions that leads to impacts for sea ice and so on, and also if there is land ice, sea ice in the Arctic. And that has implications across the world. One question for you: if there is sea ice melt, a lot of sea ice melt in one part of the world, let's say in the northern polar regions, which part of the world do you think will see more impacts of the melting of that sea ice in terms of sea level rise? If there is more melting of sea ice in the northern hemisphere, which part of the world will see more melting of or more sea level rise? And you have the same question in the other part. Think about it. This is something you don't have to answer right now. Again, you're allowed to do whatever you want to do. Google, ChatGPT, first search for it. That was the anybody guess Maldives for the other one? Okay, so I'll rate you based on the closest future. Good.
Okay. So this is the last part of our lecture. It's about yes.
Since we had this interruption, I have one other thing. So at some point tonight, the PAs will post an assignment one. This assignment one will be based on, and I sent an email to all of you. So that assignment one will be based on a book by K. Emmanuel. It's a very short book. I mean, if you the physical book is just very short. And I will have some details there. You can also search for K. Emmanuel. The idea is I want you to form groups by your roles in the war game. So all the scientists from every group will form. All scientists from each of the war game groups will form the first group for this assignment. Similarly, all engineers, data scientists, moderators, policy advocates. By the way, when I say scientists here, we include natural scientists and social scientists, etc. Science, engineering, data science, moderator, policy. Each of these group will be assigned 2 chapters, and there will be one submission which is by group, which is a short, about 10 slides, and then a short video presentation by all of you, which you'll upload on Canvas. Whether we do that online, that you will see, depending on time available. And then there will be an individual presentation where each of you will look at all the video presentations and write a short one-page summary of what. There will be more information about this assignment on Canvas, and Rian, I believe, has already uploaded K. Emmanuel on Canvas. That's available from these two. And again, you'll see more information about that by tonight. After that, if you have any questions. By the way, for tomorrow, be ready to introduce yourselves multiple times if needed, in short. So your name and, let's say, media mind. It's just that. Let's see how it goes. The president of the university apparently will join us. So have some research scholars and postdocs, and a very well-known professor who authored the eco-modernist manifesto.
Okay. So now we will look into the third part of this presentation about the impact of global warming on different domains of the Earth system. It's about oceans, it's about the terrestrial heat waves, the flooding, drought conditions, all those things. The first is the sea level rise. If you can see here the increase in the sea level rise over time. We can see how the global sea level rise is increasing. And why the sea level rising? And this is the distribution of the sea level rise over the time. The relative sea level rise is above 9 per year for this region in North America and some parts of here. And then it goes 6 to 9 millimeters per year. So if the basic information is that the overall the sea level is rising across all regions of the world. There are certain regions where the sea level is actually, the relative sea level is decreasing for this region. It is because of the upliftment of the land masses compared to the ocean. That's why you see there a relative sea level rise. Relative sea level rise is basically the relation with the land masses. If you see that overall there is an increase in the relative sea level rise across all the coastal areas. And glacier ice melting is one reason, and the second reason is ocean warming. As I said earlier, that if we increase the temperature of the water, it starts expanding. That's exactly what is going in the oceans when you see the increase in the sea level. It's not only contributed by the glaciers. The majority of the sea level rise comes from the expansion of the water rather than the melting of glaciers and ice sheets. And here's the US. I'm bringing some US related examples so that you can relate it more. You can see here that this coast, the east coast, is where we see a huge increase in sea level rises. These are the orange is basically the decade 1950 to 1959, and the blue one is the decade, the recent decade, 13 to 2022. If you see in the previous decade, we were not having that much of the flooding events, sea level rise, because of the sea level rise. But in the recent time period, if you see here, the number of flood events are increasing, and hence the flood event days in each year. So here our Boston, if you can see here, the related sea level rise is increasing there, hence the more cost of flooding there, hence we need more resilience of the infrastructure there. So why does it matter? Because the 30% of the US population lives in a coastal area. While sea level plays a role in flooding, in shoreline erosion and hazards from storms. The sea level rise not only leads to flooding, but it makes an ambient condition for the cyclones or hurricanes in USA. Not only that, if you look at the globally, out of 10 largest cities, 8 are facing this issue. They are the coastal cities. They are facing this issue, sea level rise issue. So then, the first reason of the sea level rise is the expansion. Because the oceans are taking a lot of heat, 93% of the energy, 90 to 93% of the total heat that is extra in this system, Earth system, is taken by the oceans. And if you can see that this is surface temperature of the oceans. The first 400 depth of 400 meters of depth of oceans. This is the temperature profile of those things. Not only that, if you see, look at this is basically comes from the heat content. You know what is heat content? When I say that the oceanic heat content increases over the time, what does that mean? Okay, let us say I have 1 glass of air and 1 glass of water. Which one will take more energy in order to raise the temperature up by 1 degree Celsius? 1 glass of air and 1 glass of water. I need to increase the temperature by 1 degree Celsius. Which one will take more energy? Yes?
Water.
Water. Right?
It has a higher heat capacity.
Heat capacity. Right? So, now you can imagine here, is it 20, the heat content, the amount of heat the ocean is absorbing is now around 20 into 10 is about 22 joules. This much amount of energy goes into the oceans. And when I say that, what does that 20 joules of energy mean? That if we can consume, the total consumption of energy is equal to 17 times. You can just understand how much of energy goes into the oceans. So, yeah. So this ocean is around 90 to 93% of the total global warming heat. Now, the surface temperature is increasing. The sea surface temperature is increasing. The overall, the oceans are increased. The temperature of the oceans increases. Now, what are the consequences of that? The consequences of that are the heat waves for the oceans. It's not only that we face the heat waves. The marine life also faces the heat waves. So what's the heat wave? Any idea what's a heat wave? Heat wave?
It's hotter.
Anybody from Arizona? Or southwest of the US?
So let us say that this is the average temperature at a given location. When it stays for, the high temperature stays for at least 3 days, then we consider that a heat wave event. So in a given location, when the temperature of a season or a particular days goes above our average temperature, this is what we call the heat wave. And this is what we are facing also in the oceans. If you look at the current scenario is that around 40 days, and the number of days that are involved in this one, let us say these are 3 days, and the another one is, let us say, 10 days. If you can look at now the number of heat wave days we are having globally, it's 60 days. That's 2 months. So these are the number of heat waves that the marine life is also facing. And who is responsible for that? They are not emitting, right? Okay, this is the impact of it. It changes the habitat of the marine life. When it changes the habitat of the marine life, then the fisheries industry gets impacted. Because when you have the marine heat waves, there's not much, there's a mass destruction of fishes during the heat waves. And also that we are increasing the temperature of the oceans, that actually goes to the tropical storms and cyclones and hurricanes as well. Warm temperature is an ideal condition for the hurricanes as well. So don't get surprised if you face, if you during your lifetime you'll see a lot of hurricanes as well. Because this is the reason. One is that we have to increase the heat content and the temperature of the oceans. And that becomes an ambient condition, ideal condition for the hurricanes and cyclones. So if you have planned to settle down near the coast, be careful. Then these are some of the major heat wave events in the 21st century. We have this Mediterranean Sea heat wave, the Bengal 2015 heat wave. This was a major heat wave event. It stayed for 2013 to 2015. And I highly encourage you to read about these major heat wave events. So what are the impacts on the aquatic life? So this is a 2016 heat wave event. This is called the coral bleaching. See the colorful this side? When the heat wave was striking to the coral reefs, this is what it is, the coral bleaching. How many of you know what is coral bleaching? Yeah, what is it?
When the temperature is so high, so the corals, they're very sensitive to changes of temperature, so they die.
They die?
Often they.
That's what you call coral bleaching?
Yeah.
Okay, any other definition? Yes.
I believe when coral bleaching, it's a process of like releasing the algae that's like has a symbiotic relationship with the coral. And when that happens, it's not like an immediate death, but it leaves the coral much more susceptible to starvation and disease.
Okay, perfect. Any other thoughts on coral bleaching? So yeah, you are right. There are some slight, they don't die immediately. There is a symbiotic association between the coral reefs and the algae. So when there is a temperature fluctuation, they cut that symbiotic association between the coral reefs and the algae. And when the algae goes away from the coral reefs, they start getting in the white. And if the temperature persists for a longer time, they start dying. That's what this, what is Australia? Yes, we should read about this, what happened to the coral reefs because of this major heat wave event. The whole coral reef from the coastals to around 200 kilometers they get destroyed because of the heat waves, because of this event. And now you should then learn about the economical benefits of those coral reefs. How important they are. If somebody is from the economic background and the business, you should know that the importance of these Okay, then we have another thing called ocean acidification. What is ocean acidification? Well, we emit a lot of carbon dioxide into the atmosphere. Some of the carbon dioxide goes into the ocean, and when it goes into the oceans, it reacts with the water, and it starts releasing the H positive ions, and those H positive ions are what increase the acidity of the oceans. So what? It increases the acidity of the oceans. Well, the aquatic life has a skeletal system, right? Made of bicarbonate ions. Because of the acidity increase, the number of bicarbonate ions inside the ocean, their amount decreases. As a result, they don't have much of the bicarbonate ions to make the shells and the skeletal system. Okay, that's exactly what it means, this picture. That's it. That gives an end-to-end picture of the ocean acidification. Okay, so this is what is. We are increasing the carbon dioxide in the atmosphere. We are increasing the carbon dioxide into the oceans, and we are increasing the acidity. The pH value decreases. Acidic nature of the oceans. And this marine life is very sensitive to these things. When it comes to heat waves, or when it comes to the acidic nature. Okay. Other than yeah. Carbon dioxide is the building blocks for the seashell and the coral skeleton. Now we observe, okay, there's an increase in the sea level rise. And one major cause of the sea level rise was the melting of the glacier and the ice sheets. This is what we are observing, the ice sheets, both the Arctic and the Antarctic ice sheets. This is Antarctic ice sheet and the Greenland from the Arctic side. We can see the loss of the ice over the time from 2002 to 2020. So imagine this 2746 billion ton of the ice we are losing, and that goes into the oceans. Similarly, in Greenland, it's more than that. It is 4899. So in nutshell, the Greenland is melting much faster compared to the Antarctica. So this is, they are going to face the problem is there the polar here, and they are the glaciers over the United States. All the glaciers are starting losing the snow over the time. There is no doubt this is the primary source of fresh water, glaciers. So as a result, there's a problem with the fresh water as well. And then the big companies start selling the sprinkler water, something all the time. Not only that, even the Himalayas are melting faster. Ice that took roughly 200 years to form, and Everest has melted around 25 years. So you can understand the rate at which the glaciers, the ice sheets are melting. Now the problem is there's something called the albedo effect. How many of you know this? This circle? increase the temperature, okay, I noted down. We increase the temperature starts melting, the sea ice melts, it reduces the surface albedo, decreases. Here the sea ice has a good reflectivity. When the solar radiation hits it, it strikes back. It doesn't allow it to absorb it. But when we start melting it down, then when the solar radiations comes, they get absorbed. That implies we are increasing the temperature of these ice sheets. And they start melting more ice sheets. And this feedback starts continuing going. Please note that if you look at the paleoclimatology, this was a major feedback. The temperature goes down, then the sea ice will increase if the temperature goes down. The more reflectivity, then this continues. But the other feedback, the current feedback we are facing is that temperature rises, sea ice melts. When the sea ice melts, less reflection, more absorption of radiations, leads to the ocean absorbing more heat and the more melting of it. Now, so far this was about the oceans. Now let us come over the land surfaces. I still have around, I guess. So this is about the global temperature, both oceans as well as the land masses. You can see, can you observe one thing? Or even this one, the spatial distribution of it. You can see the increase in the temperature. That's what Professor was talking about, right? The polar amplification. You can see that the northern hemisphere is increasing much faster compared to the southern hemisphere. Why is it that? Any thoughts about it? Why the northern hemisphere increases faster as compared to the southern hemisphere? Okay. If you will not answer, then you will expect in the assignment. Is there a time? Yeah, I know. I might take just 10 minutes extra. Yes. More developed countries? Okay.
I think also like we just saw, Greenland is melting faster, so that effect that you just
That will be the effect?
yeah,
Uh-huh.
it's happening more concentrated in the north.
Okay.
We just learned about like the ocean currents,
Uh-huh.
and like the Gulf Stream pulls the water up.
Okay, great. Whatever you said, there are multiple reasons for this. So I will ask you this question in the assignment. Please make sure that you cite a good research paper for that. There's a lot of noise about this question when you Google it. A lot of noise. So as a result, I would highly encourage you to cite a very good research paper when you will answer this question. And you will have to answer this question. Then when we are increasing the surface temperature, we are facing more terrestrial heat waves. So this is the study, this is the last 2023. You can see the number of heat wave days across the globe. The South America and the African countries. See that heat waves, this heat wave event, this heat wave event. And the last year was the hottest year of the century, right? So far. And when we have a higher temperature, we will expect more heat waves. And that's what we are observing. Then those who are doing the health, minors in health system, they might be much aware of these things, the impact of the heat waves on health system. Dehydration, kidney disease, mental health, respiratory disease, heat cramps, and heat strokes. Then advisory is that make sure you are at the right place. Okay, so this is the reality. So when you go go outside, make sure you don't forget the sunscreen. I forgot yesterday. And this is it's not only restricted to that, you can see the number of deaths in Europe in 2022. It's 61,000 people died.
And since you mentioned sunscreen, it's incredibly important, and especially for those of us who are a little bit, melanin. Please do this.
Otherwise, you will have this kind of. So then, the question is that when we have major heat waves, who suffers the most due to the heat waves?
The very young and the very old.
Very young and the very old. I'm talking in terms of how good we are financially. If I am good financially, I can bring the AC. If I am good financially, I will not go outside during the daytime. So this is a chart where I show that the developed nations, they are not much more exposed to the heat waves as compared to the developing nations. You can see here whether it's Pakistan, it's India, or in African countries. So that's the problem. Even though the USA will face the heat wave, but they have the infrastructure. But in India or in other developing nations, they don't have the infrastructure. They have no way but to go outside and work outside in the field. And that's why the major strokes. They don't have the health facilities there much. Okay, the one more reason, what is that? Forest fire. Increase in temperature, soil moisture is not that much, and we are prone to these things. And USA is known for these things. We can see in 2021 the number of forest fires across the world, and they are increasing over the time. The spatial spread is increasing over the time. Because of the global warming, the high increase in temperature, rainfall deficit, soil moisture content is less, and that those conditions becomes ideal for these forest fires. But we have no way to handle these things. And yeah, we are not suffering much, but these are suffering more. And but they are not responsible for it. This is about the study of USA, the number of heat waves, number of forest fires in USA. You can see from 1980 to 2025. If you observe this trend, it goes downwards, right? That's why you see major lot of papers or news articles that the number of forest fires are decreasing over the time. There are some multiple reasons of that, why it is decreasing over the time. I will not tell you those reasons. But one thing is that the area burned is increasing over the time. Even though the number of events are decreasing, the damage by the specific fire forest is larger. It's spreading like hell now. And that's what you can see observed here. Look at the two time periods, 1984 to 2001. See? Million acres per year. See how it has increased over the time. And now, after a few days, we will start receiving these messages and news articles about the forest fires. And these are the ones who are going to suffer more. The question is, who is responsible? I am not. Then we have again the drought belief cycle. We have floods, we have drought. What are the flooding conditions? Then we have the excess of rainfall over the time. And when we do not have the deficit of rainfall over the time, then we see new drought conditions. So this is the increase in the drought events over the time. And then, yes, vulnerable to drought. The problem nowadays is that it's not that the specific country is facing the drought. Nowadays, a lot of countries are facing drought simultaneously. And the problem with that is the crop production. When we are facing the drought, multiple countries are facing the drought simultaneously, then it starts the failure of the crop. When the crop is failed, then the prices rise. Those who are financially good, they don't have a problem, but the poor people are the ones who are facing it more. This is a drought, and this is a flood. This is the land, what called landslides. And landslides are also prone because of the extreme precipitation. Then again we have the drought, and this is the report from the Ministry of India. If you can see the damage due to the floods and the heat wave rainfall for the time. Look at the loss here. It's 698, around 700,000 crore loss. I would say it is the lower bound. It's an underestimation. It will be more than that. This is the loss that we are facing because of the extreme rainfall and the damage due to floods. Now let us see, this is the second part of it. Now let us see what the people think. Yes?
Talking about the drought during cycle, anybody heard about the 2011 Thailand flood? So, Danish, maybe it's one other assignment. So there were major incidents, major sort of livestock property damage. And the other very intriguing thing that happened is because Thailand at that point, and may still be, a critical node in the global supply chain of hard disk production. Suddenly there was a huge increase in the prices of hard disk because of the major floods. And one other hypothesis among many, reasons for these floods. One hypothesis is that it's because people got so much used to, people as in dam operators, etc., got so much used to the fact that they are having droughts. Where in drought-like conditions, that the water is fine, let's hold it, and by the time you realize, wait a second, we're getting flood conditions. This is a hypothesis, this has to be examined further. You might want to see what the interest is. But the fact that there was a lot of loss of lives and property and hard-based prices suddenly rose because of cascading impacts on the supply chain, those are all facts. So maybe a short assignment is to figure it out.
Okay, so we learned about the global warming, the cause of the global warming, how much the carbon emission and the impact of the global warming in terms of the climate change and different domains of the climate. Now let us see what people think about this is the share that people climate change think is a serious problem. Look at the developing USA. It's here. So this is, they're still thinking that this is not a serious problem. You may ask, what's the reason behind it? So you can answer the question. What's the reason? Why the United States is not more serious about these things? Look at these developing nations, small nations, how serious they are about. India is more serious about as compared to the United States. Australia, these regions are more serious. Then we think the national government should do more to fight the global warming. Again here, these countries, China, this country, South America, they think yes, they should take more seriously. But look at the USA. Again, it's not the priority. And what people think about, again, opinion of young people on the threat of climate. There are the papers, if you have the idea, you can read it. Humanity is doomed, family security is threatened, less opportunity than their parents, hesitant to have children. There is a section of the society in every country where they think, no, I cannot, I'm not going to plan to have children because they don't, this earth is not safe for them. There's people like that. Future is frightening, people are afraid to take care of the planet. So if you are more interested to learn about this, this is there's a paper on it. And they talk about these things. Okay. know what we are eating and how much we are eating. Your food also plays a role. What you are eating. For example, I'm eating beef. So see how much of carbon dioxide I am emitting. 1 kg of beef leads to the 99.48 kg of carbon dioxide emission into the atmosphere. Those who are vegetarian, they are on their side. So then the eggs, rice, tofu, milk, tomatoes, maize, all those things. Well, there are a lot of scientists, they think that, okay, we cannot completely change the food habit, but at least if we are consuming the meat initially for 7 days, if we are consuming it now for 6 days only, at least we can contribute something to the earth system or to the society for the future generations.
This is also something I'd like you to, I mean, we can have a class debate on this. There is, on the WhatsApp group, I sent you that article which was an interview of Professor Michael Mann, who always raises this interesting point that, shifting the blame from large corporations or large nations in terms of their policies, etc., to individuals is really a non-starter. That doesn't mean individuals should know what to do. Individuals can contribute more through by trying to make changes in policies. That being said, there are, if there are health benefits, other benefits, of course, things like this done. That's his point of view. You can read that at the article that I forwarded. You can read that what some others say. Compare contrast, this is food, there are some equivalencies that could be said about transportation, choices, etc. That can be an interesting debate. So it's like an informed debate. So take this as proposition 1 and take that other thing as proposition 2. Read up a little bit on both of these and then we can maybe one of the reflections.
So this information will be required for you when you have war games. We can literally put strong arguments to the other nation if you have this kind of information. So now coming back to our game, after understanding all these things, where is my future? Where is our future? We have seen that heat waves, flood events, sea level rise, and there is an expectation that it is going to increase in the further, right? So you will learn in the next class with Professor Edith that how we can use the Earth system model or the climate models to actually understand what will happen in the future. At least a basic understanding. So there is an expectation that since we are not reducing the carbon into the atmosphere, so we will see these events more frequently and more intensive. Both the intensity and the frequency of these extreme climate events will be more. More hurricanes, more flood events, more drought, more heat waves, ocean acidification, marine heat waves. So think about it. And it depends upon the path we will follow. We should take this path, or this path. If we want to take this path, then best of luck. We should try at least to do these 2 passes. Okay, now be ready for the quiz. So you have A4 sheets. Here are the rules of the game. You have 10 minutes. So in person, total marks 10, late submission is not allowed. This is the quiz. But there is a surprise now. Please do not write your name. Yeah.